Okay, so at this point, you should have your brand new Stars and Elements study guide downloaded. And what we're thinking about just today is what exactly did we want to notice and see with our Fusion Explore. So just a reminder, that was this activity that we were working through where we were playing our fusion game and trying to make connections between a couple big ideas: fusion, mass, gravity, and energy, of course, all happening within a star. So we were playing our game and recognizing that these different characteristics have different impacts on the star depending on what's happening, right? We had a couple things we noticed about elements in the star, not only how many of them were there, but their characteristics. We had our energy score up here, which was giving me an idea to how much energy the star had. So there was lots of analogies really happening within this game. So our goal here is to record some of those big ideas into our study guide so we have that locked in as we move forward. So you should be following along with me on your green sheet. Starting with here, just what is fusion? We talked a little bit about what this is, and we used in our class the key word of combine. This is what we're thinking about. When something is fusing, it's combining with something else. So Fusion Explorer, we were thinking about combination, like we said, of elements happening within stars. And along that same line, another term that we kind of broke down last week was the term mass. And again, we said mass is thinking about how much stuff something has, or really how many atoms, right? Everything is made up of stuff, different atoms, and depending on how much mass something has, well, that determines a lot of these star characteristics. So what we decided to do here is break down our big ideas into a T-chart. So go ahead and make yourself a T-chart over here on the side of your notes. And we're focused on two characteristics here, or one characteristic rather, two different types of stars. We can have low mass stars. We want to compare those to high mass stars. So we want to think about what do we know about stars in each of these categories in terms of some of the things that we see and we saw in the game. So I've got a little list of things that I want us to focus in on. Just this right here. These are all the things that we want to know for each star. So this is like our core list. And you don't have to copy this in. In class, we had it projected up, and we just used it to fill in our information. Okay. Really, the nice thing about this chart is if you know one side of the chart, you know the other, because they're going to be opposites. And to me, this high mass side makes the most sense. So I'm going to start there. So in a high mass star, I'm just going to scoot this over so we can also look at our game. So in a high mass star, we want to think about these characteristics. What do we know about the amount of elements it would create and the type of elements that it would create? Well, again, remember mass is how much stuff something has. So is it going to overall have more or less total elements in a high mass star? And you can always go back to your activity and check it out. But obviously, the more mass something has, the more stuff, well, it should really be ending up with more total element list. So here, what we want to make sure we do on our green sheet is not just write down the word more. That's not going to help me out later. I want to record more types of elements. That's what that really means, is that there's going to be a larger variety of elements within a high mass star because it's got more stuff, more possibility of different elements. So we got our first one. Now we're thinking about type of those elements. Well, of all those elements that exist, are they mostly going to be lighter elements lighter elements or heavier elements? Well, again, let's think about what high mass star means. It means more stuff. So that, of course, means I'm likely going to be seeing more heavier elements. Again, I'm not just going to write heavier, but I want to make sure I include that detail from the pink right here. So we have a few more things to think about. What type of size might we notice the star be? What level of gravity, fusion, energy, and lifespan? I'm going to have you pause the video and try to fill in those last 5 bullet points on your own. All right, so thanks for trying those on your own. Welcome back. Let's see if we can think through some of those details together. So first one is thinking about size, right? What does that mean for the star's size if it's got more elements, more mass, and bigger elements? Well, I think we just answered our question, right? We keep saying more, 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 more. If there's more elements and they're heavier, it's likely that star is going to grow much larger. So again, I'm just going down my list, making sure I get all these characteristics in there. Now I'm thinking about level of gravity. What does that mean for a high mass star? Well, thinking back to our info from last week, if something has more mass, gravity is pulling on it at a greater rate. We did a comparison here about the file cabinet to the Kleenex box, right? File cabinet we know has more mass, so gravity is pulling on that greater mass much more, giving it a higher level of gravity. If a star has more stuff and heavier elements, it's overall going to have a higher gravitational force. Now we're thinking about rate of fusion. This is where the game is super helpful. So remember, in the game, gravity, you were gravity by doing your swipes. So the more gravity, thinking about your game plan, what you did to show more gravity was you started to swipe faster. And by swiping faster and having essentially more gravity in our star, what does that mean for the amount of elements that could possibly fuse or combine? Well, hopefully you thought about that as more rate of fusion or higher rate of fusion. It's easier for those elements to combine if there's more gravity pulling those together. Down to 2 more. Level of energy. Again, in the game, how did we know what kind of energy was happening with our star? Well, that came from our score up here. So as I'm doing a higher rate of fusion and pulling elements together at a faster rate, what is happening to my score? We can see it continually going up here. So that means I'm thinking about my level of energy being much higher. And finally, lifespan. Remember, this is thinking about how long the star can exist for, or how long it's quote-unquote alive for, or burning its energy. And this one was figured out by if our star happened to die out or not. And some of us that happened to, and some of us it didn't, but you hopefully noticed that it was more likely, there we go, for our star to run out of fuel if I was going at a higher rate of all these things, right? My star ran out of fuel because I've literally used it all up. There's no more combinations that I can have. So it's easier to run through my fuel in a high mass star. Therefore, my lifespan is typically shorter. So now I've got my full characteristics list for high mass. Now all I need to do is take this information and flip it over here for low mass. I'm going to notice low mass stars typically don't produce as many elements. They typically have lighter elements in their composition. They're typically smaller with less gravity, a slower rate of fusion. They don't get as much energy being produced, but they can live quite a bit longer because they're not using up their elements as quickly. It's a slower rate of fusion, so we're seeing a longer lifespan. So that should be your characteristics list over here on the low mass side. So those are the big ideas we wanted to pull from our activity of the fusion game. Remember, the game's always open. You can go back there and play and see these relationships at any time.